Now we're going to solve basic rational equations. Remember, rational equations will have a denominator, and from previous chapters we learned that it was to our advantage to quote-unquote get rid of the denominator by multiplying both sides of the equation by a common denominator. This could lead to extraneous solutions, so you need to check your answers. Now, extraneous solutions mean that these answers work in a modified version, but they do not work in the original. So here's my algebraic approach. To solve a rational equation in one variable, algebraically, multiply both sides of the equation by the lowest common denominator, solve the resulting equation, discard any solutions that are extraneous values, and check the solution by substitution or graphically. Now when we do this process, three things could occur. One or more solutions could exist, no solution exists, and the solution process results in a false numerical statement, or an infinite number of solutions exist, and the solution sets all real numbers not equal to the restricted values. Solution process results in true numerical statement. So I've got some examples, so we'll look at these. Now in this first situation, there's something I need you to try and remember because it's to your advantage. If you have one term equaling one term, if you can cross multiply, it's doing about the same thing as multiplying both sides of the equation by the LCD. There are times that you don't want to do that, and we'll see that in a minute. But in this particular problem here, think about having negative 4 over 1 and cross multiply, because technically I would multiply both sides by x minus 3, which is my LCD. I would get rid of it over here, I'd have it over here, and cross multiplying would result in the same thing. So let me move this on down. So if I cross multiply, I have 2x times 1, 4 times x minus 3. Distribute, because you see now we're back to something that we've done. Upon distributing, there's my negative 4x plus 12. I'm going to add 4x to both sides, and then divide by 6, and my solution should be 2. Well, let's substitute 2 in and see what happens. I think we can do this in our head. So if I put 2 in for x, I have 2 times 2, which would give me 4. In the denominator, 2 minus 3 would give me negative 1, and 4 divided by negative 1 does give me negative 4. So that's my correct answer. In this problem, I see denominators on both sides. Actually, the only denominators I see are x minus 1. So I'd multiply all terms, this one, and this one, by x minus 1. Multiplying this one, I get rid of the denominator, so I end up with 2x. I've got to remember multiply 5 by x minus 1, and multiplying this term by x minus 1, I'd end up with 2. So now you distribute, combine like terms, and we could move the 5x over. Let's see what I did. Okay, so I subtracted 5x, so I'm congregating all my x's to the left-hand side, and my numbers are staying to the right. Divide by negative 3, and I end up with x equals 1. But notice right here, if you put 1 back in, to check like we did earlier in problem 1, 2 times 1 is 2, but 1 minus 1 is 0, and we can't do that. So that is an extraneous solution. So I go no solution. You might just do a slight little X on that and indicate no solution. And that, remember, was one of my possibilities. Let's look at these next two. This one looks sort of similar to this one. Let's see what happens on this. So I'm going to multiply everything by x minus 7. Remember, multiplying here should give me a 9. I'd have plus 3 times, in parentheses, x minus 7. And on this side, I should end up with 2x minus 5. Distribute. See, 3x minus 21. Now, collect like terms. which is what I did here, because all I could do is 9 minus 21 gives me a negative 12. Get your x's to one side, numbers to the other. X equals 7. This is another one. X cannot be 7. So there's no solution here either. Okay? So make an X and just indicate no solution. That's all you need to do. So this is something you need to fill in right here. Well, let's look at this one. I do have one term equaling one term, but if I tried cross multiplication, we'd end up with q to the third. We haven't done that, haven't gone there. So let's not cross multiply here. I think I would factor out the denominator here, and that would be, I believe, q minus 4 and q plus 2. And my lowest common denominator would be q minus 4 times q plus 2. Since I've already got q minus 4 here, it's contained in this one, in this particular denominator. So now this is what I need to multiply both sides by. If you need to, just write it on both sides, just sort of up in the upper part, and cancel and see what you've got left over. So you see, I factored first, checking my denominators, then q minus 4, q plus 2 is my lowest common. So if I multiply both sides by this, think about this. On this side, this denominator would completely cancel out. That's why I've got a 42 left. On this side, the q minus 4s would cancel, and I would have q plus 3 and q plus 2. Guys, this is a quadratic. I need to FOIL this, bring the 42 back over, because when you have a quadratic, remember, they're different from linear. They all collect over on one side, and let's see, this one factors. I would have q plus 9 and q minus 4. Set them individually equal to 0. And I'd have q equals negative 9 or q equals 4. Let's try this. We'll check this one. Negative 9. Store in for x. You could put q, but I mean, it's quicker just to indicate x wherever I've got q's. So I always go back to the original. Do not go back to a modified. Go back to the original. So I need parentheses, x plus 3 divided by x minus 4. Let's see what our answer is. And on the other side, we've got 42 divided by x squared minus 2x minus 8. And if we end up with the same thing, yay. Okay, so negative 9 works, so check that. Let's try 4. And I'm going to do second enter. I've got to do second enter a couple of times to get back up to the very, very first one. There's that one. So let me hit enter. Ooh, doesn't work. Exit out. This is why you need to check, okay? So on this one, I've only got one solution, and it's that right there. Don't go mental, don't go erasing. Just exit out, and this is your answer. The only time you say no solution, like what happened in problem 2 and problem 3, is when the only answer I've got doesn't work. In problem 4, I've got 2 possible. One doesn't work, okay? So that means all I have here is x minus 9. Or, excuse me, q equals negative 9. And thank you. That's it for this video.